So, how does linear regression works? We want to fit a line to the data, and in 2 dimensions, this takes the form of y is equal to ax plus b, and in the 2 dimensions, this takes the form of y is equal to ax plus b. Using a single feature is known as a simple linear regression, where y is the target, x is the feature, and a and b are the model parameters that we want to learn. And a and b are also called the model coefficients, or the slope and intercept, respectively. So, how do we accurately choose values for a and b? We can define an error function for any given line and then choose the line that minimizes this function. Error functions are also called loss function or cost functions. Let's visualize a loss function using this scatter plot. We want the line to be as close to these observations as possible. Therefore, we want to minimize the vertical distance between the fit and the data. So for each observation, we calculate the vertical distance between it and the line. The distance is called residual. We could try to minimize the sum of residuals, but then each positive residual would cancel out each negative residual. To avoid this, we square the residuals by adding all squared residual. We calculate the residual sum of squares, or RSS. This type of linear regression is also called ordinary least squares, or OLS, or ordinary least squares, where we aim to minimize the RSS. When we have two features like x1 and x2 and one target variable, a line takes the form y is equal to a1 into x1 plus a2 x2 plus b. So it fits the linear regression model. We specify three variables a1, a2, and the intercepts b. And when adding more features, it is known as multiple linear regression. Fitting a multiple linear regression model means specifying a coefficient an for n number of features and b. For multiple linear regression model, Scikit-Learn accepts the one variable each for feature and target values. Let's perform linear regression to predict blood glucose levels using all of the features from the diabetes data. So first we import the linear regression from sklearn.linear_model. Then we split the data into training and tests. Initiate the model, fit it on the training set, and predict on the test set. So here, the difficult metric for linear regression is R-squared, which quantifies the amount of variance in the target variable that is explained by the feature. Values can range from 0 to 1. With 1 means the features completely explain the feature target's variance. Here are two plots visualizing high and low R-squared, respectively. To compute R-squared, we call the models dot method, passing the test feature and target feature. Here are the feature only explains the 35% of blood glucose level variance. Another way to assess the SSE regression model performance is to take the mean of the residual sum of squares. This is also known as the mean squared error, or MSE. MSE is measured in units of our target variable squared. For example, if a model is predicting a dollar value, MSE will be a dollar squared. To convert the dollars, we can take the square root, known as the root mean squared error, RMSE. Here, to calculate RMSE, we import mean squared error from Scikit-Learn-Metrics. Then call the mean squared error. We pass the y_test, y_pred, and set squared equal to false, which returns the square root of the MSE. The model has an average error for a blood glucose levels of around 34 milligrams per deciliter. Now let's build a multiple linear regression model. So I'm using my Jupyter notebook. I'm passing the diabetes data. Before passing diabetes, I need to import my pandas. Then I import the pandas data frame. I'm using the head to see what are the values are there. This time I'm taking all the values. So wherever the zero are there in a glucose and BMI, I'm removing that values, and I'm taking X as all the values. Earlier I picked the BMI as the X value, but now I'm taking all the values. So this is the multiple linear regression. This is the Y value. To split the training and test data, I'm using this code. Then I'm passing the linear regression model for all the features. I'm predicting. This is the prediction. First, I'm calculating the mean squared error. This is the value 0.35, and R squared. This is the value for R squared. This is the R squared error. So if you see this, 35% of blood glucose level variance is there. It explains this R squared error. Will call the model score method passing the test feature targets. Here feature 1 explains about 35% of blood glucose level variance in this score. Whereas 24, this is the mean squared error. It is the model has an average error of blood glucose levels of around 24 milligrams per deciliter. That is about this thing. And yeah, we will connect in the next session. Thank you.